So our robot was designed to detect objects and rough surfaces on Mars, and our robot is designed to detect those surfaces and to be able to maneuver around them correctly and safely, so it can transport materials or whatever items we decided to transport on our robot.
We will use what we learned in this project in Mars because Mars is a different breed. Like, there's different materials, and it's going to be challenging to have a robot up there and help us do things. So we need to learn how to get it to remove from things and not get in the way. So that's what we learned.
We will get this done by using ultrasonic sensors that will maneuver the robot around objectives or anything, and it will also pinpoint a location that it will need to go.
This Python code controls an EV3 robot to move forward and avoid walls using an ultrasonic sensor. So first, it imports the necessary libraries for motor control, sound, button sensors, and virtual sensors. The objects for motors A, B, and C, sound, button, radio, and various sensors are created. Motors A and B are assigned to left motor and right motor variables for easier control using tank drive or steering drive. So the main loop here, it's an infinite loop to continuously perform the start moving forward tank drive on 2020, which starts both motors A and B at the speed of 20 speed units specific to the EV3 wall detection. So if the ultrasonic sensor detects an obstacle within 20 centimeters, the threshold was increased to 20 centimeters to prevent premature turns due to sensor noise. Stop on detection. Tank drive off brake equals true. Stops both motors if a wall is detected. 90-degree left turn. So tank drive on for seconds, minus 20, 1.2. Performs a left turn by setting motor A to negative speed, motor B to positive speed of 20 for 1.2 seconds. This needed adjustment based on the robot's turning radius and the speed. The negative speed for motor A makes it rotate backwards, resulting in a left turn. Short pause. So the time.sleep 0.5 adds a short half-second delay after the turn. Resume forward motion. Tank drive 2020 starts both motors again to move forward. Time sleep 1 adds a delay of 1 second to allow the robot to move forward a bit before checking the distance again. Second turn, if the ultrasonic sensor detects a wall equal to 10 centimeters, it will it checks the distance. If it's now centimeters, adjust for a closer turn. The second turn is optional and can be removed if a single 90-degree turn is sufficient. Tank drive off, brake equals true, stops the motors again. The tank drive on for seconds, minus 20, 20.8. Performs a shorter left turn for approximately 60 degrees. Adjust the time based on the robot's turning behavior. Time sleep 0.5 as a short pause after the second turn. Continue moving forward. Resumes forward motion. Short pause loop iteration. Time sleep 0.5 adds another short delay before restarting the loop, allowing for more smoother movement between the iterations. So, problems that we had during this project were where the robot wasn't consistently making accurate 90 and 60-degree turns. The adjustments were needed in the timing for each turn to achieve the wanted angles, and the initial turn values led to over or under rotation. The second turn was closer to 160 degrees. Fine-tuning was required to make sure each turn stayed within the specific degrees. The robot sometimes went in the wrong direction, particularly on the fourth turn. This required checking turn commands this required to check the turn commands to ensure they were correctly set to the counterclockwise direction as needed. The ultrasonic sensor was detecting walls or obstacles prematurely, causing the robot to turn before it reached the intended proximity. The distance threshold had to be adjusted multiple times to ensure that the robot was only turned when it got closer to the wall, preventing earlier unwanted turns. There was syntax errors. I encountered a type error related to unconnected sensors, specifically with input 1 and input 2. This often happens when the sensors aren't correctly or properly connected properly, or aren't recognized in the code, which is needed to ensure proper connectivity. A name error was raised due to a incorrect input incorrect input configuration in input 2, which required verification for sensor setup. There was incorrect comparison operator. I accidentally used 1 equals which is assignment operator, instead of double equals for the equality operator in a condition, which led to a little syntax error. Timing and adjustments for turns. Due to the inconsistency of the robot's turning behavior, timing for each turn had to be carefully adjusted. By fine-tuning it, I was able to perform the correct turn angle of 90 and 60 degrees. To make all the turns consistent without excessive rotation, specific timings were set, and delays were added between the movement to stabilize the robot's behavior. And that's it.
So as Mateo said, the obstacles just were like our robot kept bumping into it, and the ultra sensor wasn't picking up at first. We had to find our code and put it to different values. That was creating it to hit it. So if you have a higher, you couldn't do at first, they give you the option 0 0. So we took it out and then put the ultra sensor in there, and then we gave it something to hit before, and this allowed us to kind of be able to not touch the objects. In this project, I also learned that it takes a lot of patience when you're building your code, building the obstacle course, doing all that. It takes a lot of patience to make sure everything is right and that we can get it done. Because with Gearbot, it's kind of hard because the sensors and everything doesn't tell you exactly what it's going to do. You have to just see it for yourself and then learn it, and then put everything together and process it to get what you want. So that's kind of what I just learned in this. So yeah.